This is the lesson for Mod 12, Lesson 0, Parts of Circles and Arcs. In this lesson, the goals we're going to look at are identifying parts of circles and identifying arc measures for parts of circles. The first thing we want to make sure is we know our vocabulary that we're going to use for identifying parts of circles. So if we have a question, we know what the question's asking us to do. So a circle, which we've obviously seen before, a circle has a center. And so in this example, we have a circle with a center at Q. And we always name our circle based on the center. So if I was going to name this entire circle, for this example, I would actually name it as circle Q. So a lot of times we note that with just a symbol of a circle, and then I would write a Q next to it. So we would say that this is circle Q. A radius is defined as a segment that goes from the center to any point on the circle. So for this example, we have a radius of PQ or QP. You can name it either way. We also have a radius of QS or SQ. And then finally, we have a radius of QR or RQ. All the radii of a circle are that same distance from the center to the circle, so all of them are going to be congruent segments. A chord is defined as a line segment where the endpoints are on the circle. So you can see like PS or SP. This is a segment where we have 2 points on the circle. So this would be PS, or you can call it SP. That's a chord. Another chord, though, actually would also be PR, right? So a chord, again, is just where the 2 endpoints of the segment are on the circle. So we have PR. And then the last one is the diameter. So a diameter is really just a chord that goes through the center of the circle, right? So it has a similar definition to a chord. The only difference is it goes through the center. So PR is a chord, but a more specific name for it would be the diameter, right? So we would call it the diameter. A secant is another term you might see. A secant is a line that intersects a circle at 2 different points. So I can see here that line J is a secant, so it intersects at 2 points. A tangent, it's a little bit different than in trig when we say an opposite over adjacent. That's more when we're looking at, if we graph a tangent line on the coordinate plane, we might see that relationship a little bit more. In this diagram, a tangent intersects at only 1 point, whereas a secant intersects at 2 points. So a tangent is just going to touch the circle at 1 point. So in this case, line K would be a tangent line. And the point that it intersects is called the point of tangency. So in this case, M would be the point of tangency. So that's where our tangent line intersects the circle. For this first example, we're going to be identifying parts of the circle. So again, we name our circle with our center. So our center is A, and we would call this circle A. A radius, we actually have a couple radii. That radii is the plural of radius. We have a couple radii in this problem. So we have AD, we have AC, and AG. So we actually have 3 different radii here. We name a line segment with 2 letters and a segment notation on top. So we actually have 3 different radii here. For the diameter, remember the diameter has to pass through the center. So DG or GD would be our diameter. A chord would be any segment where the 2 endpoints are on the circle. So that would be FB. Or you can even include the diameter in that if you like. A secant line, again, is the line that intersects a circle at 2 points. So this secant intersects at F and B. When we name a line with points, you're going to use 2 letters or 2 points, and then you put that double arrow. So FB or BF would be the secant line. The tangent intersects the circle at 1 point, and we name it again with 2 letters if it's points on the line. So I might call it EC or CE with a double line. And the point of tangency is it intersects at point C. The next topic we're going to look at are arc measures. So really that is taking degree measurements that are part of a degree measurements of a circle and equating them to different parts of the circle on the outside. We already know that a circle is 360 degrees. So if I was to start at the center and rotate around, we already know that's 360. So what we're looking at is going to be talking about arc measures. So that's, again, relating degree measurements to part of the circle. So a central angle is basically an angle that's formed by 2 radii of a circle, and it's at the center of a circle. So for example, if I had, let's say, angle APB was 60 degrees, angle APB would be a central angle, right? So it's formed at the center of the circle. We then talk about something called a minor arc. So a minor arc is if I look at my central angle, the part of the circle that falls within that central angle, that's going to create the minor arc. So if the central angle is 60 degrees, my minor arc that goes with that would also be 60 degrees. So how we would write that is this, the 2 endpoints we have are A and B. We're going to write a little arc on top of it. So the arc measure is going to be 60 degrees. All right, so that's just taking the part of that angle measurement at the center of the circle and relating it to the outside of the circle. So minor arcs, though, are less than 180. So anything that's less than half a circle is a minor arc, and we name it with 2 letters. A major arc is what happens if I want to find the other piece of the circle. For example, right? So I'm going the other way around. These both still have the same endpoints of A and B, but we need to signify we're going the other direction, and it's the long way around that's bigger than 180. So a major arc we name with 3 letters. So I would call this A, and we use a middle letter so it has to pass through, let's say, C. And I would say that ACB would be the other degree measurement. So if this is 60, 360 minus 60 is 300. And this would be 300 degrees. So like the major arc would be 300. Okay, so anything that's greater than 180 or greater than half a circle is considered a major arc, and we name it with 3 letters. And then the last thing would be if we have a semicircle. So a semicircle is if I have it's formed by a diameter. So like let's say if I was to add another letter here, let's say I call this letter D over here. A semicircle is 180 degrees. So typically we name a semicircle with 3 letters. It's sometimes named with 2 letters, but basically if it's formed with the diameter, it's going to be 180 degrees. So a semicircle is going to be 180 degrees. In this last example, we're going to be looking at finding our arc measures. So the easiest way to do that is first by identifying our diameter. So XU is a diameter. TW is a diameter. And so any diameter is going to form 180 degrees. So if I already have that, we have 130. If I subtract, I would have 180 minus 130. So we get that to be 50 degrees. We also know that we have vertical angles because these diameters actually made vertical angles. So we have another 50 degrees. All right, and then we can use our second diameter to find other angles that maybe we need, or even the other half of that first diameter. So I can do, if I look at this, is also 180. And then I can subtract to get that missing arc measure. So 180 minus 50 minus 60. We would get that to be 70. All right, and then now we can go to our question and kind of answer those different pieces that we're asking for. So the first thing they're asking for is XW, so that's going to be a minor arc. So XW is going to be 50 degrees. We then have VW. If I go from V to W, I can see that's 70 degrees. We then also have USV, so USV, so that's 60. VTW is going to be a major arc, so if I go from V to T to W, I can add up all these smaller arcs. I can also see it's really everything except this 70. So I can even subtract 360 from 70, or I can add them up. And we're going to get that to be 290. The next one is UV. UV I can see is 60. And then finally the last one we have TXW. And we can see that's going to be a semicircle of 180. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.